All right, so now I'm talking. So now is when you stop talking. I have a lot to go through. I'm taking the same quiz no matter what I get to. So let's make sure we get to it. Because again, a lot of you think it's been tough so far in circles. Wait till today and next week. Which kind? Like the defensive gas stuff. So dry erase.
No, why would you dry erase?
There's some people use dry erase microphones.
I need pencil.
I'll have to find one. They don't have any. There used to be some there, but they don't. All right, so I'm going to give you a process. If you're struggling, if you get it, then if you're very visual, this stuff's not that bad, but some people were really struggling yesterday. I want to know for arc MN, so that is the arc. I want to know what angle corresponds to it. There's a whole bunch of lines. Well, there's, again, I said this for the, listen. Can't say E. There's 4 or 5 angles coming out of me. I have no idea what angle. So you have to say 3 letters. And it's not NEM because the vertex has to be in the middle. So we don't remember how to name angles apparently. E is in the middle. So here's the process. No, I was agreeing with, some people said it, some people said it wrong. Can't answer both groups at the same time. Some people said it wrong, some people said it right. Here's the process. If you don't see where that came from, if you struggled on that, do this and it'll work every time. Like there's no way if you practice it, this won't work. You start, well, we're gonna follow it into the angle and out of the angle. I'm gonna start at M and I'm gonna follow a line coming out of the arc, coming out of one of the points of the arc. I go out, follow that line, and I get out there. Now, if I can trace a line back to the other side of the arc, then that angle matches that arc. Is there a line now going from Q to N? No. Then that doesn't work. That's your process. Trace one line coming out of the arc across the circle to a point. Now, cross the circle to a point. Now, I can come back and go to N from that one. So, and again, E has to be in the middle. Some people said E and M. You can say N-E-M. You could flip it around M-E-N. Doesn't matter the order, but E has to be in the middle. Cannot say it any other way without E in the middle. So now, next one. Let's get rid of that one. So now that I'm talking, I shouldn't hear anything. I do. Right, Gabby? So, you can quietly reach down and pick it up. I don't think that involves noise. Yeah, somehow I don't want that. So EF is our next arc. Again, same process. Gonna be the process. Well, I'm gonna do the process. So again, pick one of the points on the arc. Trace a line from, if you're getting it, great, fantastic, but some people aren't, so I'm doing this for everybody, not just for the people getting it. I trace a line out from the arc. Can I get back to the other side of the arc? Absolutely. There are, exactly, which some of you probably missed. E, P, F. We're not done. You can have more than one angle. If you remember, there was specifically a theorem that we learned that said if we have an arc and if we have 2 angles that share that arc, oh no, that's fine. I can say that. Those 2 angles are congruent because they share the same arc. So you can have more than 2 angles that share an arc. You cannot have an angle that has more than 2 arcs there, because if I'm at an angle, I can only create 1 arc. So you don't have to worry about it the other way around. So that's why I'm only really doing it from the arc to the angle, because that one's a little tricky. I'll show you the angle, like how to go from an angle to an arc in a minute, but there's like, that's not. So now, got one, but we need to keep going. We'll switch to So, well, again, I'm just gonna do letter by letter. So I'm doing arc EF still. I pick the next line. I go out there and I get back to F. Yeah, so there's another one already. First two lines work. So again, N is the vertex. N has to be in the middle. There's another angle already. We'll switch to green. Trace the next line out. Can I get back to F? No, so that one doesn't work. I can get rid of that one. There's no angle there. Trace the next line. Can I get back to F? So that's your process. Trace a line out, then try to go back in. And if there's a line going back in, you have an angle that works. Any questions on that before I show you the how to do it? Like if I say, what's the arc for the angle? Yeah, much easier. Not really many options on this. If I were to say, what is the arc for angle RHP? Well, I tell you, what's the arc for that angle? You can look at it visually and come up with it real quick. There's only one option. Yeah, you just trace the line. Literally all you do. You go from this letter to this letter to that letter. That's it. I go from R down to H, up P. So the arc is just the part of the circle in between those two. I'm not super worried about balancing up on them. So the tricky one is going from arcs to angles. And again, you'll never get something that complex. Or if you were good on that, you should get move. Well, that's not the math part. Hey, when you find somebody to beat you, that's called a tennis team. Find somebody to beat you.
No, I think you in the phone quarter. Yeah.
I will put any amount of money that you can put up on tennis if you like. All right, so here's where it gets real. So let's refocus. You got a little time to go in the beginning. It is about to get complex.
Let's get to it.
I'm going to line to a circle is your lesson. So page 227.
These all gonna be separate.
Oh, shoot. Crap. We gotta finish. Well, did we get through all? I don't think we did example 5 in here, did we? Or did we? Did we? We did 4 and 5 in here?
Yeah.
All right. I'm gonna just quickly go over them for the video, so I won't spend any time with them.
Four.
That's 5. Okay, so really quickly, this is again mostly for the video. If you want to follow along, if you weren't here, but I please be quiet.
Okay.
Being as nice as I can be, starting to build, and some people care. And already screwed up by letting the people that don't care as much affect the lesson. Won't keep doing it. So again, mostly for the video, but if you want to follow along, this is a specific theorem. It's the theorem about using the diameter and creating a triangle, basically. If we have an inscribed triangle. We also said, though, well, wait a minute, I don't really need to know that theorem. If I understand this is an inscribed angle, right? Because the vertex is on the circle. We know that the end points are the diameter. So the arc associated with an inscribed angle, which in this case is that arc, the arc is 180. If I remember that very first theorem, half of the arc is the angle, so that is a right angle. So that's all you need to know. These are the measures of the angle. The other two angles, M and K. So angle plus 90 equals 180, or these two will always have to equal 90. If this is 90, we could just say this plus this equals 90 also. Either equation works. All right, so that's that one. You can try the check on your own. Oh, it's jacked up. Why does this one keep jacking up? So this one was the other theorem. It said, bless you. Not equal to each other on this one. So in this one, and again, they don't do a great job of drawing it in, so you can tell. This was the other theorem right after that triangle one, actually. That said, if you have a quadrilateral inscribed in a circle. So again, if you want to memorize the theorems for Monday, that'll work for Monday. Not sure if you'll retain it for the EOC. It said if you have a quadrilateral inscribed in a circle, opposite angles, actually they're not congruent, opposite angles add up to 180. So again, just memorize, there are like 5, 6 theorems, whatever it was in that lesson. But again, you got to add all the other theorems we're about to learn today. Opposite angles add up to 180 if you have a quadrilateral inscribed in a circle. But we also said, well, wait a minute. If I just needed to kind of figure it out, if this is my angle here, and again, I'm kind of focusing on the two that have X in it because that's really the only way I'm going to be able to solve is to have one variable. If that's my angle, well, this is my arc. Again, you just have to understand when you see the EOC that it's an inscribed angle. So inscribed angles and arcs are going to be what you think about. Well, if that's my arc for that, here's the opposite angle of E. G is the opposite of G. So my opposite arc for G is that part of the circle. I've made a full circle. My arcs are the entire circle. Well, if my arcs are the entire circle, then the arcs would be 360 added together. So arc, whatever that would be, F, G, D plus just DF would be 360. Well, then my angles in here have to be half of them. Again, back to the original theorem. The angle, the inscribed angle is half of the arc. So you can figure it out from that original one also, or again, if you just want to memorize that other theorem, you can do that as well. So I think that was all the examples I assigned. Oh, that was the check problem for it, same problem. If you did not write this down, page 221, 1 through 10. You wrote it down for sure. But page 221, 1 through 10, 1 through 6, I told you was the exit ticket. A little bit late for that now, if your exit ticket's today. Page 222, 13 through 31. I could have sworn I've written this like a million. Oh, there we go. I was gonna say, no, I wrote that again. So there it is right there. This board is so good. Oh, no, that's the problem. There. So that's, and there's a, oh, not sure how that part is weird. There's a chance you will see the exit ticket again. I thought it was a super easy one, but based on the performance in the second period, we may be putting that on the quiz again. Like not as an exit ticket, like it'll just be a problem. So you may see it again. You get your one shot at it today. Again, so all that will be on potentially Monday's quiz, along with what we do today, which we got to get through pretty quickly. So now turn to page 227. Right. So 227. Yeah, just wait. You think it's bad so far? It's actually a pretty short lesson, but it is a very, again, some of you may be like, well, that's not scary. There were a couple people said that's not that bad. And then a couple people were like, their eyes were glazed over, and I thought they were gonna think. So we'll see. Tangent line to a circle. I'm gonna kind of go a little fast just because I'm recording and I want you guys to have maybe a little practice time for the exit ticket, since it was a little tougher than I thought it was gonna be for some of the group. So you have a circle. I'm gonna kind of put the circle over the top of other stuff. You can still see it there.
Is it all gonna be one grid?
Yeah, I've been doing that because then the exit tickets help you more. So I try to just do whatever works out better. But with the exit tickets included, normally if I break the quizzes into more grades, it kind of means the exit tickets don't count as much if I'm giving you more. All right, so if I have, what is a circle? I'm not going to spend as much time with that. That's how many degrees. What is a circle? There's a lot of round objects. What's a circle? It is a shape, but what kind of shape is it?
A shade.
I can't use a word to define a word. Doesn't have any edges, but that doesn't tell me what it is. You're telling me what it isn't. A polygon. Because it doesn't have sides, that's why a polygon has sides. We actually went over this. How is it created? Let's think about how it's created. Remember when I talked about the field where they saw the like gigantic drawings in the field with wheat and crops and all that kind of stuff, and how the guy did it? Oh, how was it created? You're on the right track with what you got.
Oh, it's.
So close. What do we do with those points? How do we get those points? How? Well, we actually don't think. So a circle is really a set of points. Every line is a set of points. Straight line, curved line, when you get into algebra 2, every line, when you see a line, it's not a one thing. It is an infinite number of points and just, or so, I mean, it's infinite. Like you can't see distance between them, so they look solid. So they're all technically answers to some equation. Every line, well, I shouldn't say every line, but what you deal with typically in math has some equation behind it. It's all the points that would make that equation true, make the left side equal the right side. Same thing for a circle. When it comes to creating a circle, like physically creating it, we're just finding from a central point, we're just finding a whole bunch of points that are the same exact distance from that point. That's what that compass tool thing is that you used way back in the day. That had a super, super sharp pointy end. You stuck the pencil in the other side and you're spun it around. It's not the tool for making circles. It's actually the tool for creating an equidistance from a point. So like all these are the same distance. That's what equidistant means. All those are the same distance from that point. You can do the same thing with a ruler. Wouldn't be as perfect, but if you took a ruler, put a point here and said, I'm going to make points that are 5 centimeters from that point. And if you just kept doing 5 centimeters all the way around, you'll make a circle. It'll look just as good as it would as like that, or if you use a compass or whatever. I actually did that when I had more time in geometry a long time ago. So with that in mind, that's what a circle is. So if these are all individual points, here's what a tangent line is. I take one point, which is impossible to even draw. Even computer-wise, it's pretty much impossible to actually draw. It looks like it doesn't even touch the point when you draw it. Here, I'm actually going to use the drawing tool because it's really hard to do this otherwise. So I'm going to have to move where that point is. Actually, I'm just going to redraw it. A tangent line is a line that goes through one single point on a circle. Definition, go through one single point. So it has got to, like, it's literally, oh, actually, I'll show you this. It's like you took the line, it's not on the circle, not touching the circle at all. And you keep moving it closer and closer to the circle until it eventually hits the very first, because remember, it's a curve. So there is one point that's the farthest out from the circle. You stop as soon as you go through that one single point. That's a tangent. Now, oh, it's why not no why. That's what it is. That's the definition. Now, what it is less important than the properties it has. The main property it has, which it says, I think it says it yeah, well, actually it says it right here. Here's the main property of it. When we have a tangent line to a circle, that tangent line is perpendicular to the radius or diameter, since they're really the same thing as far as the angle they're at. What's perpendicular mean? So if I draw a radius in, this I'll do just by hand. If I draw a radius in to that single point where that tangent line hits the circle, that has to be a 90-degree angle. The only way you can have the radius touch the point that is also the point that is on the tangent and on the circle. You'll also see this happen a lot, which we'll get to today. You'll also see a line drawn in from one of the sides, might even be drawn in from both sides of a tangent. And if that's 90, that's 90. What am I creating when I do that?
A triangle.
Ooh, a right triangle. What's going to come into play, do you think? A squared plus B squared is C squared. So last lesson that came into play, your last quiz that actually came into play. I think that came into play Tuesday. Remember correctly, I think there's something where that came into play. It's coming into play again. This is another reason why I said circles are so difficult, because they pull in all kind of stuff from old lessons. Your EOC will do a lot of circle stuff, because then they can pull in stuff from old lessons and test you on two things in one problem. Other than that, there's not a whole lot you really need to know theorem-wise. We'll go over a couple. I think there's a couple. The problem is all the different types of questions they can ask based on just that one concept. Really quickly, and I'm not doing anything with this. I don't know what they would even do on the EOC with this. A common tangent line just means that you have one line that is tangent to multiple circles. They say two, I think, but I don't know why I would have to stop at two. At least two, probably. So I'm not going to do anything with that. I think I might have had on the old quiz, but I don't know why. It's kind of, there's no math behind it. I mean, oh shoot, we do have to do this one too. And they don't even give you an example on this till way later. If I have, here, let me do a better job. Little circle this time. So I have a circle. I have this point. That's crazy. I have this point outside the circle. Oh, oh.
I used to rap.
Yeah, let me just go over this one and then you can go. This is definitely something you need to see first. So I have this one point, we'll make it blue, that's fine. Outside the circle. So that's what in this theorem, exterior means outside the circle. So you need to write that in where it says exterior point. Exterior means outside the circle. I'll just do this. If I draw in a tangent line, so again, one touches one point of that circle. But then I draw another tangent. Oh, I missed it. I'll move it. I draw in another tangent line. That thought? I think there's a picture later in your book, but this line segment or these line segments. So again, those are both tangent lines. They have to be congruent. That's the only way you can draw in two tangent lines from the same point, is if they're the same. So we'll name them A, B, C. So AB has to be congruent to BC. Only way you can have two tangent lines coming from the same. And that's a big one. There's math associated with that. Luckily, it's pretty easy math because you guys normally assume, like when you set equations up, you typically just assume things are equal anyway. And this is one of the cases where that'll be right. So I won't spend as much time on that as I'm going on the other stuff. Well, if they're not touching the circle, there wouldn't be tangent. They have to be touching at one point. And they would have to tell you, like, well, actually, they wouldn't have to tell you. If I did this, because remember, the first theorem said if you have perpendicular lines, they're tangent, right? Or if it's tangent, they're perpendicular. The opposite is true. If I tell you these are right angles, then that means those lines are tangent. So I actually don't have to tell you a line is tangent. I could just draw in right angles, and you would have to know, oh, well, because that's a right angle, the only way that can happen is if those two lines are tangent in the circle. Otherwise, they'd go through the circle if it wasn't a right angle. So then they'd touch more, or they'd miss the circle altogether. So if I tell you that's a right angle, I tell you that point A is on the circle and point C is on the circle, you don't really drink. Please be careful, but don't. Especially something without a lid, that's the worst thing. So that is something that will happen, I think, if I remember correctly, in the future stuff. They'll just put right angles in there and tell you point A is on the circle, point C is on the circle. You have to then know those are tangent lines. All right, with that in mind, I want you to do example 1 and example 2. On example 2, I don't actually care this time if you look at their solution because they don't really ease you into problems in this. Well, example 1 is easy. Example 2 is not easy. I don't know that you'd figure that one out. You will when you read their solution, I think, but on your own, you may not have made the connection. So now, yeah, where's the? Oh. Oh. I'll give you, what do we need on these? I'll give you like a couple minutes, then I'll probably say something to help you with example 2. And I'll give you a couple more minutes. I'll do attendance manually since I sworn I had a little skinny highlighters. Oh. Stolen money. Was that? Oh, I do have one right there. All right, who do we got? Oh, no. Miles. Oh, no, we already went over. We have 1.5 100. So,
That's my.
is this lady called you go yet?
Stop it. I still
Not on board with that. Did you tell her? Tell me about.
I don't know.
You need to say that. I want to see on this. He'll laugh. He didn't finish me. He went over that. She laughed and she got for you going home. She goes, no, I'm gonna go. But it was late. It was like 3:15.
Yeah.
Maybe three pretty good.
She come.
So hot. I don't know how you guys roll on that guy. It's so hot. Yeah. I saw his name was on the 100, I think. Originally, 100 or 400, like within the last week. You were listed, and I don't, we didn't run, like we scratched. Yeah, but I saw you on one of the photo things. We didn't run it. You may not even know your name was on it. We didn't plan on running it. Your name, I think, was on a short one originally. I'll go back and. Okay. Yeah, we can tell.
I would die. Wait, what? So Mr. Gill, Mr. Gill.
Yes, ma'am.
We can use the thing that they already give us, right? It's like the short. Is that what you said? You say you died? It's short, why? I'm not, it's not. Sample 2, we can use the game of study. What the hell? I mean, like. Like, are you sure which? No, like how they say, like the Pythagorean theorem, multiply it out. I see that.
Well, yeah, they're showing that's how you do it.
Okay, is it
Yeah,
like
there's-
these?
Yeah, that one's a tricky one. I don't know that you would have made that connection initially.
Okay.
But here's what I want you to understand, why they do that. That's what I want you to think about, why they do that. Would I have known to do that on my own? Now you do. Yeah. I mean, it's again kind of solved out for you. You're just waiting for whenever they
Put
come.
a 3.
Somebody out.
I don't understand this.
Jacob, I got.
Common tangent.
Laura.
And when they share,
Laura.
line shares.
You only got one ear. You did both of those? Good.
Oh, wait, the
All right, so again, I question whether you guys would have known that.
What are you writing on the white? I can't
Stay in
wait.
attendance, 'cause I'm recording, I wish. Not, I mean, I've done this, so it's not a big deal.
You could just cut it
I
out.
do it all the time.
It's also edited.
Good.
Yeah.
Right.
I'm trying to stop, bro. Stop, bro.
Or just open the cup and just, yeah, right. I'm not doing that.
I know.
She said.
I'm not. Professional.
All right, we're done with that, so we'll go ahead and we'll go through these really quickly. Quick for me, because we got, these are not the difficult ones, so we gotta get to the difficult ones.
Go.
Well,
You know, you're
Oh,
not.
this one?
yeah, sort of, you don't really need to, right? 225. There you go.
You're not.
All right, so. When we have this, oh, let's do this one really quickly. Again, I'm talking again. So when we have this, again, I just tell you, I'm not there. That's not on my coach. This is just, do we have one line that is tangent to two circles? Really, you don't know. Like that's the thing about this and why you can't tell if a line visually, you can't tell if a line is tangent. You can't tell if it's going through 1 point versus 2 points of a circle when a circle is an infinite number of points that are so small you really can't even see them. How do you know if it's going through 1 or 2? That's why I think it's a dumb question. But anyway, if it's just touching, so we have to assume it's only touching 1 point, I guess, which would mean, yes, that's a common tangent. This one again, only assume it's only touching 1, so it is a common tangent. I would say technically that's a common tangent. It touches both circles at 1 point. I didn't see anything in the definition saying that if it's the same point, then it's not a common tangent. So maybe it's not common. I don't even know. These are definitely all common tangents here. They all touch 2 circles. I'm not worried about it for me. I just went over it because it's in the book. Yeah, it is tangent to 2 circles. I would say, I mean, there's nothing in the definition that says it can't be the same point. Just says it's tangent to 2 circles. Well, technically that's tangent to 2 circles. So I'm not worried about it for my case, so I'm not gonna. Oh, that's right. I don't know. I guess. So now we do need to worry about the next one. So what is the concept in that? You kind of see what they did. Why did they do that? What's the concept we need to understand that leads us into that a squared, b squared, c squared thing? That is a great question, isn't it? I ask a lot of good questions. Let me go. You got to see this. By example one.
2. I was just looking at like how they did it. And it don't really make sense. Cause they said.
Well, I just asked a question. Anybody answer it? What is the concept?
Pythagorean theorem.
Why? Why do we use that? How do you know? I don't see a right angle mark.
It's perpendicular to the.
So that is your concept. If they, so again, they tell you this for a reason. They tell, oh, actually, shoot. No, they don't. We're determining if it's a right triangle. So they're asking us, is it perpendicular technically? We do the same math, doesn't change anything. They are asking, is this line tangent? Well, if the line is tangent, this would have to be a right angle. Well, the only way it can be a right angle is if a squared plus b squared is c squared. Kind of like your last quiz, if you remember. There was a question, I'm sorry, not your last quiz. The quiz that's due tomorrow, which not many people have made up, or retaken or made up if you missed it.
Well, you know, bigger.
So, that's been in focus for a while. So if that is perpendicular, again, it would be a right triangle. If it's a right triangle, it would mean a squared plus b squared is c squared. There's one more piece that you gotta know. Which side, if again, this is a right triangle, which side would be the hypotenuse? So the right angle would have to be there, right? So the hypotenuse would have to be AC, but AC said it's only 6. How can that be true?
Because it's, I disappeared anything? How did I try?
There's something you need to connect in the figure that they don't make as obvious as you are used to it being sometimes. The 6 is not the whole line.
But I just said that. I just said that, Mr. Gill.
I didn't say it.
But why didn't you say I was right?
Because then everybody stops thinking about it. And I didn't want people to stop thinking about it. A lot of times people say the right answer and I don't stop. If I don't want. No, not very often. It has happened. Has happened. So, actually, you say the right stuff a lot.
Thank you.
I don't know why you don't come in and do some retakes, because you're fantastic grading this class. For me, it is about me, if I want you to be successful. Why are you getting embarrassed? You turn red, you kind of turn red. You want everybody to look at you, everybody look at this going. I'm having so much fun doing that right now. So, anyway, we have to make a connection that this line is actually the radius of 9 plus that little segment that is 6. So that's just purely a visual thing. You just have to understand that's how figures work. They are only going to write a number way to the right side of a line if it's only a part of the line. Otherwise, they would have written it right in the middle. They might have even done that thing where they, write line and a line here and say that whole thing is 15. So that's just you doing more problems and getting used to the way they create figures. I don't know what the EOC is going to do. They could do something slightly different. So just the more problems you do, the better off you'll be. So again, that is also 9. Now AC is definitely the longest side because it's 15. 15 squared plus, equals 9 squared plus 6 squared. You did not do the math on that. It comes out to be 225 equals 305. They did it for you in there. The math part is not the hard part, though. The hard part is understanding what you're supposed to do. And there's no check, I don't think, on that. So you'll have it. Oh, make sure. I haven't even assigned these yet. Make sure I do it right now. Go to the practice problems and circle that section where it says example 2. I don't know the page, so don't have to be paid.
How are we supposed to know the page?
Right.
You keep going until you hit the practice problem. It's only like 3 pages ahead. It can't be very far because this lesson's not that long.
2:30.
So you'll see where it says practice, and you want to go down to the section where it says example 2, and then has a bunch of problems. Those are the ones you're gonna have to use to practice since they didn't give you a check. Oh, is it on the next page? They said in the last doc it wasn't a check.
You don't have a
Fine. I didn't think so.
I was.
All right, so next. And again, we spent more time on that than we will on the other stuff, because that was the lesson part. So I want you to try to do example 3. If you get to the check, you try to do that. Try to do the example without the help. You need the help on this one, though, it's fine, because you do have a check probably.
I need the help.
Again, this is not easy. I'm not telling you this part. I told you the last 2 weren't too bad. This is gonna get tough. Look at that. Can. I can and I will. that. Math you do there. Will be just a- It's not the expert. Cannot square a term. What is squaring a term mean? What's 3 squared mean? It means 3 times 3. So that is x plus 2 times x plus 2. Again, you gotta think way back to algebra about how you do that. You remember a thing called foiling? Foiling. So you go, yeah. I've never. That's what I'm talking about, how they did the math on it. So again, the key is, they show you really how to set it up. X plus 2 squared is x plus 2 times x plus 2. That's when it's kind of like the distributive under the way, we draw the little lines. Squared. We're gonna do it up here in a second. It's kind of like it. It's not really that kind of thing, but you're taking the x part and multiplying it times the other x and the 2. And you take the 2 and multiply it times the other x and the 2. I'm gonna do it, so you don't, but again, that's just algebra. That's not geometry. That is not geometry at all. You're supposed to know how to do that. Well, again, we will not go over that stuff, so you may have to brush up on your algebra. Oh, oh, no. I haven't decided. If you want to create it, you can create it.
Video games.
I have, oh, that's gonna be a very small, not many, a ton of shirts. You need to expand it, be like, what else can we put in that would be related?
We can set up on the touch, we set up 4. But only after the math, what would you get on that?
A C, just standing up as a C. If you did that for every problem, like, if you can set it up and show me you understand the geometry concept, that's. Always. Gotta do it every. Now, if you can only do the geometry concept for a couple and not for a couple, then that's not, like, it's, you gotta be able to get to at least the concept for every problem, and then you're at a C. And then depending on how much math you can do on them, then you go up from there. I actually talk about that in this problem. It is itself a problem. It's actually not as bad as it looks. There's one piece that a lot of kids didn't remember.
The only one like the only one I kind of like, but I know how to do it, but I don't know why I do it like that. Is example.
Well, and again, remember they're doing a lot of it for you, so there's also a difference between kind of like seeing what they do and being, oh yeah, I see what they do, but then you having to actually come up with that out of your own brain on a quiz when you got 4 or 5 other problems, that's the tough.
Like, how do I know in the or if I did
People are not gonna think authentic.
or the inscribing?
Well, if you're going from the angle to the arc, you multiply by 2. If you're going from the arc to the angle, you divide by always, there's no exception there. Write that down in words right now. So we're gonna do from here to here. To here.
Yeah. So you like sort of. Oh my God. What?
Hello, ocean. That's not saying so much.
Yeah.
Nothing's like
Laughter, did I not say that laughter attracts me?
And you were there.
It attracts sharks.
God knows what, I don't get
Why don't I get to work?
Why do we get to work? You guys
said the arc
they've
to the
done the whole
angle
problem for
is
you. There's nothing to do. They've done it. You gotta fill in a few blanks.
The art.
So this is not the time to goof off, because all you're gonna wind up being in a world of hurt in a week, less than a week. I mean, you might be in a world of hurt already. I haven't graded Monday's quiz. So we'll see. There, again, there's no plugins. That's the thing. Calculators won't save you on these lessons, so. You shouldn't really even need a calculator for this one. Because all the tough stuff goes away. It winds up being a pretty easy problem, actually, even though it looks tough. And the part that is tough, you can't do in a calculator, and it has a variable.
You said the arc to the.
Oh, I
angle
didn't
is
finish
times
that.
2.
Say it again.
The arc to the angle is times 2.
For the inscribed.
Yes.
Yes. No. Angle to the arc is times 2.
Okay.
Yeah. All right, so I'm drawing this larger since zooming in tends to mess up the document and stuff. So I'm just gonna start drawing stuff. All right, so this is a tough problem. The example 2 was a tough problem. There are no easy problems if you haven't noticed on this quiz. So I'm not sure you're gonna get many easy problems on the quiz on Monday. There might, well, I'll probably give you the, depending on how the exit ticket turns out, when I grade it, I might give you that one over again, which would be the only possible easy one, but there's gonna be a lot of tough problems on here. So you need to think, maybe my goal is not going all the way to the end solution. Maybe my goal is just make sure I can set the problem up.
Yeah, that's.
You can set it up, that's a C. You can set every single problem up correctly. Can't do any math, like any of the algebra, which is a little trickier. That's a C.
The algebra is easy.
All right, so in this problem, they tell us, so that's the key, that it is the SQ is tangent to the circle at point Q. They also tell us, I believe, well, they don't tell it to us, but they draw in a line segment from R to Q. You can assume that that line meets at Q if they're drawing it from R out to the circle. So what do I know? What does that tell me? Here's the main concept you need to get out of this so far. Really the only. Nope. You're jumping ahead. Main concept. This is what leads you to that. You're just looking at what they did. How did they do that? Why did they do that? What do they know that lets them do that? Why? Again, you guys are just going backwards. You're seeing what they did. You're going, oh, well, then it must have been a right triangle. Can't go backwards because that part won't be in there for you. You have to make this connection. They told you it was tangent. So that means. Don't read what tangent means again. Go back to the first theorem on tangent.
The tangent line.
Yep, very first theorem on tangents. The theorem, not the definition. Back to the first theorem. That's all. There's only one thing you gotta remember. Oh, what'd you just say? So what's that mean? 90 degrees. That's why they did it. Again, you guys are relying on the solutions. And then when you get to the quiz, there's no solution. You have zero clue how to even start it. If you look at the solution, that's fine, but don't then just do the math. Go, why did they do that? What led them to be able to use a squared plus b squared c squared? It had to be, somehow there had to be a right triangle, but why was it a right triangle? It's because if they tell you it's a tangent line, and if you connect a tangent line in the radius or the diameter, it has to form a right angle. Only way you can connect a radius or diameter with a tangent line. Now that I know the concept, we can get into setting up the problem. I'm going to slide all that stuff. Oh boy. Probably not going to be able to do that. So I don't think I can zoom in anymore. Oh, I can. All right, that'll be enough. So with that in mind, I have a right triangle. Again, a little tricky because that side's pretty easy, one variable. That side's pretty easy, one number. What's going on the, what side is RS? It's the what? That is the hypotenuse, right? It's across from the right angle. So that's going to be my side C. That's going to be side C. So I can say a squared, doesn't really matter which one. Or x is a or b, doesn't. A squared plus b squared. That's why it keeps messing up right there. Ooh. Huh. Hold that thought. All right, I can't fix it. So that's as good as it gets. You can see the square though. So what do I put on the other side? Don't look at your pages. C, side C is x plus 2, not x times 2, because some people try to say, oh, that's just 2x. It's not 2x. I'm gonna do it with the x first. It is x plus 2 is the length of RS. Add them together. And then I have to square that whole thing. That's what your first or second, well, actually, here it is. Oh, so there, just to fill in the blanks, if you're filling them in for later, that equals RS, or I'm gonna write SR squared, because that's the side C. Now, if you want to fill it in, I've written it in for you. They put 4 squared there. They did the x squared first instead of the 4. So now, this part's pretty, I'll flip it around so it matches their stuff now. That part's pretty easy. 16. That you can do in a calculator. This part you can't do in a calculator, and I guarantee you most of you don't know how to do that. Some of my like post algebra 2 kids get that wrong all the time. That is not just, oh, I'll just make that x squared and that 4. Not how you do that. What does squaring a term mean? What does 3 squared mean? Now, what is the answer? How? What's it mean? Thank you, how? Say it again. So what does it mean? What's the math we're doing? It's 3 squared. What math are we doing? What math are we doing? 3 times 3. It is not 3 times 2. You don't multiply the base and the exponent. You are multiplying the base times itself twice. So this, I'm going to write it there. We'll change colors, so we'll stop. I'll write it here. X plus 2 squared means this. X plus 2 times x plus 2. That does not come out to be x squared plus 4. So here's the part that you guys were asking. This is when you did foiling in algebra. Been a while. We haven't really had to do it in here. You take the x times both terms. That's why I say it's like the distributive property. Never seen it though, huh?
What's foiling, bro? What?
Literally what they called it. Go ask your teacher.
Everybody
What do we
calls
call
it
that? Right. Go write that for them and say, what do we call that? So we
Nobody
did
calls
that.
it
It's foiling.
I don't know.
Yes, they do. Yeah, absolutely. No, they don't. No, they do not. Distributive property is one number, because that's not called, that's not distributive property. Distributive property is specifically one thing times 2 things. Go out, whoever your teacher is, I will write her an email right now. What is this called? She'll send it back going, foil.
You're my teacher, bro.
We're algebra? I don't teach algebra,
Oh.
bro. X times X is what? No. 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 I don't remember. No. 2 times X is 2X. So X times X can't be 2X. X times X is what?
X times X.
No.
X squared. X is.
Wow. There we go. Somebody tried something different. Literally have one of them sitting right there. X times X. Because what is, we just said a squared term, 3 squared means 3 times 3. So if we go the other way, x squared means x times x. Well, if I have x times x, then I have x squared. We just said that. So now here's the only tricky part of this. I take x times 2, right? That's this one. So x times 2 is 2x. But then I do that again, because now I have to move to this 2. I'm done with the x. I move to this. Well, I need to multiply 2 times x again. So I get that a second time. What is that equal? 2x plus 2x. So that's your other blank. And then the 2 times the 2 just gives you plus 4. So it is not just x squared plus 4. There's a term in the middle when you FOIL, it will have an x in it, which is the 4x term. There's actually a shortcut memorization thing. Clearly, we don't memorize things. We don't remember anything later. So I'm not going to teach you the shortcut method. You need to understand how to FOIL. When you guys, a lot of you are going to be in Algebra 2, that's a gigantic part of Algebra 2, is multiplying what's called polynomials together. Multiplying them, dividing them, all that.
How does that become 12 though?
Well, so now we're gonna start solving. So we have our original this was technically our original, but we multiplied that out. So now let's talk about what does solving for a variable mean?
Oh,
Solving for this.
Wait, no, I didn't teach. Who did I teach 1A? Nobody? Oh, it's almost always. I taught her. Vicky, I did, but she's not. I said it in here before. What do I say solving for a variable really means? Yeah, I told you were 1A. What did I say? Solving for a variable really means we're just doing what?
Solving for that.
Yeah, but there's a more specific, I'm trying to do what with the variable? What do I want to do to solve it? I want to get the variable what? Alone, right? That's because think about it. When we say the answer, we say x equals some number. So x is alone. X is all by itself. And then on the other side, we have a number. So we're just trying to get the variable all by itself. I got variables on both sides. Can't be by itself. It's on both sides. I need to get rid of it on one side. So I'm just going to do the way they did it. And I might have chosen this way. I don't know. They chose to get rid of it on the left. So to get rid of it, if I have an x squared and I want to get rid of it, I just subtract it away. It goes away. But what's the number one rule of solving? You remember that one? So if I do x or subtract x squared on one side, and again, it has to go underneath the term that has the same exponent. So x squared subtract x squared. Well, what happens on both sides? The x squared goes away. That's why this turns out to be not as difficult as it looks initially to solve, because we don't have to deal with an x squared at the end. It actually just goes away in the equation. It goes on both sides, just goes away. So we're left with a relatively simple equation now. Then you would, so that, whoop, I'm gonna laugh. Oh yeah, 4x. So 4x plus 4, you should be able to solve that, and that'll answer your question about how they get to 12. So I'll give you shouldn't take more than a minute to wrap that up.
wait.
Ooh, I'm glad you mentioned that because I was gonna ask a question and everybody's gonna get it wrong. Now nobody should get it wrong. I'm still gonna ask this. So what's my first step, Logan, since you asked that question? What's my first step to solve for x? Again, I still want to get x alone, and I got a bunch of stuff on the same side with it. So what do I do first to get it alone? Well, you see, sound like Jacob. Well, you see, I mean, not today. Today's just happening. Which is a rough day to be, actually, any day now is. Logan's eyesight looks like my eyesight.
No, sorry.
Well, hey, you don't have to tell me, Sarah. I grade your question. And I grade them in pens to make it even worse. Come on, you should know how to solve a two-step equation. Can you see it? So then tell me, we subtract 4 from both sides. So that's my first step. And again, this answers your question of how they got to 12. So we get that. Oh, are we done? Why not?
Because you are.
What do we do when we solve for a variable, especially in geometry? If you're still taking algebra EOCs, then you need to make sure you understand this also on your EOC stuff. When we solve for a variable, we read the question. They may just say solve for the variable. They may just say solve for x. This one, they do actually just say solve for x. So we don't need, I don't think there's any other part of the question. I don't know. Yeah, x is the same number everywhere in an equation or a problem. You have 10 x's for one problem, they're always the same number. Well, again, they didn't, I mean, you can write that in, but they didn't ask for it in the problem. It's never a bad idea to go back and fill in stuff. So for this particular problem, x is 3, they don't ask for anything else. If you want to solve it out, then yes. The other side, the QR is 3, and the side C would be 3 plus 2 or 5. I'm gonna just keep going so we get through everything because we didn't in the other class. We'll come back. You'll probably have a little time to do that check in a minute. It's a similar concept. It's complex math. You're gonna have a variable and a number in parentheses that you wind up squaring. So it's not necessarily x plus something, but similar concept. All right, so here is our next problem. Let's do this. Oh yeah, we do. So I have a circle. No, because we're on, when we get to the lesson on hearts, I'll draw it. Can't believe you just asked me. I have two lines drawn in. Normally you won't see this extra part of the line. So I know. Well, the eraser won't erase a line. Are you talking to me? Eraser won't erase a line. I would have to like try to redraw it, and sometimes it's tricky to get it to stop it. My screen's acting like it's not very cooperative. It's not cooperating. So what theorem is this from? How you gonna explain it? Say the number, and the number can help us. So again, they would have to tell us, and they do tell you in the problem, they would have to tell us those lines are tangent to the circle. So if this is a point outside the circle, which what's the word they use for point outside the circle? Exterior point. If those two lines are tangent, which they would have, or if they didn't tell you that, they would have to somehow show you that, which they could do by doing that. Well, that wasn't a very good right angle, but so they could do this, and that would mean also that they are tangent lines without telling you they're tangent, but somehow they would have to be tangent. Then it says again, I think you said it, but just to make sure, what's true? They are congruent. They are the same length. Those line segments have to be the same length. And like, I don't know how to explain, like, if I'm taking two lines and moving them closer to the circle, like there's no other way I can just barely touch the circle without them being the same length. Like if I mean, I can't even, like, that's just an intuitive thing. There's no way I can think of to try to explain it. We could do a proof on it and prove it, I'm sure, but that doesn't help explain it really intuitively. So if it doesn't make sense to you, then you just got to memorize that one. Yeah. Can't, but like I could move this point around again, and if I went to that circle, you'd see it went through the circle. So like if I, let's say I slid this point down a little bit down here, I'm going to keep this line tangent. Well, to get to that point, I'd have to go through the circle. So there's only one way, and that would be a longer line if I went through the circle, because basically this point got closer to this point when I moved it down and farther away from that point. So the only way they can both be tangent is kind of be basically right in the middle of those 2 points on the circle. So same length. Like I said, just if that doesn't make conceptual sense, intuitive sense, and you just got to memorize that one. So with that in mind, let's do the math real quick. Luckily, this is one where you guys would probably just guess at the right equation anyway. So I want you to try to do that one on your own. Yeah, I've been to men, so they.
But it's not her headaches.
I don't know, because I move them around. And I take them off in between.
What? What? You push your head there.
That's.
Oh, no, sorry, no, it's like. That's even more than.
You can hold your head when you want to.
Yes, I sleep with this circular thing to keep it nice and round.
You actually.
Yeah, it doesn't say nice and around.
I need to try. Well, let me do it.
It's literally a bone, not much more than bone.
But like your skin, you can try it. And your skin just.
You hear how loud that was, right? I do have like, anybody know who Charles Barkley is? Like, he's way before your time, but he's like, Chicago Bulls, you would know, because he was that era.
Yeah.
So Charles Barkley, if you look at his head, like Google Charles Barkley, you look at his head, he's got a really fundamental like this.
Oh, you're in that.
Oh, that was super loud.
Not the fellow.
Good thing this was always last. You should pretty much be done. Not super tough equation. I'm not gonna zoom in. I'm just gonna set the, whoa. What in the world was that? Oh. Oh my, how in the world did that happen?
Wait, let me do it.
No,
Wait, I
You
want
were.
to do it. I
you
can't.
were, you go work. You can do it after you finish working and we're done with it. Yeah, that's what they say you're supposed to do. All right, so the equation, oh, it's still not working. Let's try it. Sometimes it works in a different, no, not really. It looks like it's like a cool, super cool script font, but it's just not. That's not my handwriting, that's the board not cooperating. So that's the equation, if you can read that, it didn't. 7, you just set them equal. The two line segments are the same length, they're congruent, so you set them equal to each other. And then they've solved it out. Again, if you have variables on both sides, you have to think about getting rid of them on one side. So subtract 5x from both sides. Then you have to add the 9 to the other side. Again, they worked fine on this side. I don't know why it worked on this. And I think that was the only one there. So now let's go to the last page of the lesson. All right, so we didn't even get to this in the last class, but I wanted to make sure we got through it because I'm recording again in this class. So look at the theorem 10.13, last one you got to know for this lesson. This is new. This is the first thing. The only thing you really had to know up to this point is tangent line is perpendicular to the radius or the diameter, whichever one you have. That's all you really had to get from what we've done today. Now we got a new one. And this one's a little trickier. So it says if I have, again, two line segments, right? So that's my SQ, SR, and they tell us they're tangent. So somehow we either be told they're tangent or we probably will have a converse where we could go the opposite direction. Most likely they'll tell you they're tangent. So the central angle, oh God, so that's a central angle, right? I'm not gonna write over the top of this stuff. It's not looking good. Well, I'll leave that because that one's okay. It says that if we have a central angle, actually they say circumscribed angle. Huh. I would not have called that a circumscribed angle, but what angle are they talking about? What's the circumscribed angle? Not P, that's the central angle. That one you should know. What would you say the circumscribed angle? We talked about a circumscribed circle, not circumcised. I'm surprised that's the first time people laugh, because we've used that word a couple times, and I was like, whoa, nobody laughed. Have we? Not yet, you gotta see it, and you may not. Listen. Right. Well, it was when we drew a circle around a polygon. So inscribed when we put something inside, circumscribed when we put it around the shape. That's why the inscribed angle, I'm sorry, the inscribed angle is in a circle. That's not inscribed. So circumscribed is the outside. It's going around the circle. That S is your circumscribed. So the angle that goes around the circle, that's tangent to the circle, basically. Those lines, that's another way to tell you that those are tangent lines, basically. Wrote in the wrong spot. So you need to write this down. That tells you that the lines are tangent. So there's another way to tell you lines are tangent if there's an angle involved. They can say it as a circumscribed angle. The definition of that means that the lines are tangent in circle. So make sure you write that note. Circumscribed angle means the lines are tangent, line segment. All right. So with that in mind, it's telling you that. Oh, I worked on that. Close enough. Those two angles have to add up to 180 degrees. So down here, I gotta zoom in on this one. It might kind of mess everything up, but is everybody got that right? Or anybody writing those triangles? Okay. So this is, I think this is gonna wind up probably messing some stuff up, but there's no other way to really feel. I don't want to try to redraw all of these. Oh, and there it is already. No, I don't know why it does not cooperate when I try to zoom in, but it does not. What page are we on? Oh, okay, yeah. Gotcha. I thought I was skipped to the whole wrong lesson. All right, so here we go. Getting closer. Oh, there we go. That's fine right there. Get rid of that. I don't. Oh, again. And now my board is really jumping. So for all of these, so for a circumscribed circle, normally is going to be what you draw around the polygons. Oh, actually, I'm sorry. They're drawing the polygon around the circle. All of these lines. Oh, here, I'm going to have to do it on the computer screen. So here, all of these points are tangent points. If the polygon, ladies, the polygon is circumscribed around the circle, all of these points are tangent points. I'm drawing it around the circle, drawing a bunch of tangent lines to the circle. So the concept you need to know when I say that is a circumscribed polygon, all those line segments are going to be congruent. Not necessarily like to all of the other ones, just two to each other. So in this case, I knew that's that. All right, so back to this. So this, who's behind me a second? How's it on the arrow, but then it draws. So that line there, this is going to take forever. Here, let's try this one. That line there is congruent to that line there. Both of those lines are tangent to the circle, and they come from an outside point. So if you have a polygon that is drawn around the circle and it's telling you it's circumscribed, that means you got a whole bunch of tangent lines. So write that note. Got a whole bunch of tangent lines going around the circle. These are not tangent lines, and one of them they don't even touch, so it couldn't be tangent. These are actually tangent lines here, so you would have some, but then those are not. So I can't use those. So in this one, where it's not symmetric, you still have some tangent, so that's tangent to that. And again, these would be different numbers of markings, like 2 markings and 2. I can't really draw it out great with the screen all jacked up. But all of those points outside the circle would have 2 lines that would be congruent. They're tangent to the circle coming from the same point, which is again that same theorem we just went over. It just kind of takes it to the next level. Well, I did not do that. Oh. That's all. What page are we on? 229, right? All right. So again, if you have that, it also would mean that the angles added together, don't forget that piece. The angles added together, if you have a central angle, it's only if you have a central angle and that angle outside. That's good. So if you have a central angle, this is a different theorem. The central angle and that exterior angle add up to 180. Maybe we'll probably go through that again before the quiz Monday. That's not going to be on the quiz study meetings. Actually, yeah, go. Yeah, you still can. I didn't get to it in second. I'm not gonna try to make them learn it on their own. You'll get a little more because it's not one of the easier ones, so you'll get a little more, and we'll do maybe a lesson on why that's true. So here's your problem. So now you can just practice for, you got a couple minutes of practice for the exit ticket. That's probably what I would suggest. Exit ticket is 221. That's what I said earlier. 221, 1 through 6. If you already did it, you can try to do one of them again. If you think you got it down, you just want to look over your work, whatever you need to do. If you think you're ready. The other problems from the last lesson, just so you know, 222, 13 through 31. I'm going to assign some from this one. Oh my God.
Don't you basically take the, since the arc is big, you take the arc and time divide two?
Well, there's more
Or you
to
make
it.
the angle.
That's a part of it. Angle times 2, arc divided by 2. But again, some of those are a little more complex than that. So make sure you know how to do all 6 of them. And look over them real quick. Make sure you can say, yeah, I know how to do this one. I know how to do this one. You don't want to actually go through and do them. Oh, let me do this because otherwise it's going to mess up again. I'm going to tell you the problems from this lesson for Monday in a second, so you can keep practicing. What? Huh.
You said if the angle is bigger, it's divided by 2?
Hold on. Let me get this done. I can tell you what problem.
Because the 1 through 5, the arc is bigger.
What in the world? Why is it showing?
Yeah.
One more time, and I gotta try something. Yeah, that is not working. So let's get that out of the way, maybe.
What happens?
Hold on. I'm doing something. I know you guys always think stuff's important.
It's pretty.
Until you think what I think is important, I'm not really worried about what you think is important. That's it. But I feel like you guys don't think that normally, so that's why I'm not super worried about it. There you have it. So that's why I'm not super worried about what you think is important. When you start to think what I think is important, then I'll start to think what you think is important. Math and money go together. No doubt about that. All right, so here's your practice problems that you're responsible for. Page 231, everything. So what does that go through? Ah. Here, I guess I have to use this. So the whole page, yeah, hold on, that my board is just even more off than it was a minute ago somehow. It's not a game. Hold on, we're getting there. So it looks like 1 through 14 is on 231. So 1 through 14 is on 231. Now on 232. Oh, I did it again. God, I'm gonna lose my mind. Or I'm gonna break the smart board, one of the two. So 232. Let's now, and it always resets for some reason to that. Hold on. Oh, is it open? Oh, it's not supposed to be open. Thank you. So I'm telling you, I'm assigning problems right now. 232, pretty much that whole page again, too. Oh, crap. All right, we got to do the exit ticket. All right, I'll write that up while you're doing the exit ticket. So yeah, when you get started. You should still be able to finish it. It took most people like 2 minutes.
What's the date on today? Is that 11? Oh, 11. Oh, it's 11. Thank you.
You're welcome. Now raise your hand if you don't have one yet. Make sure I have plenty of different versions. Easy peasy. So go ahead, get started. If you need to work a couple minutes, again, you know what you're doing, shouldn't take long. You don't know what you're doing, then you go. Exactly like one of the ones in that section of 1 through 6. Different numbers. Anybody else doesn't have one? Ah. What are you doing? Don't go. It's in the notes, shake that hand. Don't know what you're doing. Not that you'll be able to do it anyway. Time. So you've got a couple of minutes before the bell rings, but if you do need a couple of minutes to wrap it up, that's fine. I'll send an email out to anybody. I mean, you can see what people are finishing. Not to be talking to ourselves out loud because other people are hearing what you're saying. Done.
You have a lot of lights.
How do I, can you have it? You don't have it.
Huh?
Nothing worked. Sitting there looking like a dick. Dick was asleep all the time. He had brought it up. You're working? You had that stuff down. I told you look at that. Number 6. Like,
I didn't know how to do it.
number 6. Am I working? Like I said, I gave you
So I still didn't know how to do it.
Say you had no enough.
No, I said I went to 5 then. I said, I don't know what the time is. That's why I assumed.
Yeah, I ate lunch anytime.
My legs hurt. Like when you missed, everything your retake.
Did you get over 40?
Yeah.
Not yet, yeah.
Fine.
I got it in the neck.
Yeah, those are ones you don't want 100 on, because you're gonna deal with some tougher food coming up. Already got all yours?
This is recorded. You forgot.
Yeah, well, actually, I need to stop it.
Oh, nice.
Next we have like.
Can't do that.
Yeah.
Next we, so we look at, Valley, how,